All right. So the angle, don't spell angel, by the way, angle of elevation is the angle between the horizontal line from the observer and the sight line to the object that is above the horizontal line. So I have this guy's eye or girl's eye right here. And so the horizontal is level with the eye, and then the angle formed looking up to the object is what's called the angle of elevation. So now if I look the other way, if I happen to be up on a, say, a cliff and I'm looking down, guess what that's called? The angle of depression. It sounds sad, but it's just you're looking down, so it's depressed. Okay, is the angle formed between the horizontal line and the observer and the sight line that's below the horizontal line. So depression is below the horizontal line. Angle of elevation is above the horizontal line. So just some terminology so you know. Okay, so let's do this question. A man who is 2 meters tall stands on a horizontal ground 30 meters from the tree. The angle of elevation of the top of the tree from his eyes is 28 degrees. Determine the height of the tree. So you notice that I don't have the tree drawn in here, but the tree is essentially, you know, here, right? So the height of the tree isn't just this triangle, it's also the 2 meters that the guy stands, right? So do you see this is going to be a two-step question? Not only do I have to find this right here, which I'll call, I don't know, x, I'm going to have to do what to it to get the height of the tree afterwards? Yeah, I'm going to have to add 2 to it, so it's not that hard. Okay, and so again, the reason why this is called angle of elevation is because it's horizontal looking up to the tree. Okay, so now that we look at this triangle here, what trig ratio would I be using to solve what x is? Nope. Tan, yeah. You'll notice that a lot of these word problems, just as a little hint, a lot of the word problems seem to use tan a lot. Because usually we don't care for the hypotenuse when we're looking at heights of stuff. So it seems that tan is always used because they're always giving you the opposite or the adjacent, and you have to find the other one. So yes, tan of 28 degrees is equal to opposite, which is x, divided by adjacent, which is 30. Okay, so we're going to round to 1 decimal place here. Hopefully everybody can punch it in their calculator. Make sure your mode is on the right mode. Ooh, okay, so I was going to mention this from the quiz and stuff. If we're rounding to the nearest 10th, and the 10th, it happens to be 9 and we're rounding up, don't just write 16, go 16.0, so then we know it's a rounded. If you write 16 as a whole number, then it looks like it's not a rounded amount, right? So this would be 16 meters. Therefore, the height of the tree would be what? Yes, I'm going to say approximately 18 meters. Everybody understand how I got 18 meters out of that? So again, watch on the test. You remember to put the units in. So if it's angle, degrees is units. And then watch for lengths. So if it doesn't mention units in the question, then you don't have to worry about units. But of course, angle is always degrees. So, we good? Okay, let's move on to the next one. Oh. Kelson was standing on the top of a coastal cliff looking at Laura, who was in a boat below. The angle of depression to Laura from Kelson was 30 degrees. The cliff was measured at being 100 meters high. What was the angle of elevation of Kelson from Laura? Okay, so I want you to draw a diagram here of this situation. So I'm going to give you a second, because if I just provide the diagram, then that's half the battle, right? So you need to come up with a diagram of this situation, and then we'll go over it, okay? Look, here is a cliff. And he's going to pair, like, and here is the water, right? Here's the water. Here's the cliff, right? Here's Kelson. I'll put K for Kelson, right? Yes? And Laura's in some boat somewhere. So here's a boat, right? Here's Laura. Yes? L for Laura. Okay, so it says the angle of depression to Laura. So from Kelson. So Kelson has a horizontal like this, right? And it's saying the angle of depression to Laura. So that means it's like that. Do you see? That would be 30 degrees. Is that how you drew it? Somewhat like that? And it says the cliff is 100 meters high. So this is 100 meters. Yes? Okay, so if I were to continue this horizontal across and vertical down, do you see we have two triangles that are the same? Yes? So can anybody, and maybe I'll just make this a little bit, I know the water doesn't look like a side length or whatever, but if I were to go across like this, do you see I have two triangles that are the same? We're ignoring the waves and all that stuff, right? Okay, so can anybody tell me where another 30-degree angle is or another 100-meter height is? Yep. Like right here? Yes, right here. Okay, and very good. The way to remember this is anytime you have a Z, those inside angles are the same. So if I write it the other way, that would be the same. Okay? If they're similar, if they're the same triangles. So anytime you have that Z, automatically put that other 30-degree angle there. And then where would the 100 meters be? Right here? Yes? Okay. So, and then of course, then we have our 90 degrees and 90 degrees. Yes? So, what is the angle of elevation of Kelson from Laura? So, Laura, horizontal looking up to Kelson, would be 30 degrees as well. Do you see that? Kelson looking down, that's the depression, is the same as Laura looking up. So remember that when you're doing any future problems, because of that Z feature, the angle, the person that's below looking up would be the same as the person from up looking down, right? Okay, so does everybody see? There's my angle of depression and elevation all good to go. So, who can tell me how to figure out how far Laura was from the base? What trig ratio would I use? I heard sine, but it's tan. Again, I will repeat, a lot of these word problems are tan, and the reason why is they usually want the ones that are at the 90 degrees with each other. They don't really care about the hypotenuse because it doesn't, unless you're like, there's a situation where, for instance, there's like a soccer field or something like that, and you know, or a football field, you're not going to walk to get to the other corner. You're not going to walk all the way down the length and all the way down the width. You'd go the diagonal. So maybe that would be a scenario where they'd ask that. But a lot of the times the question is you know, the height and the width here. So yes, it's tan 30 degrees is equal to opposite, which is 100 over the width, which we'll call x. So x is approximately, oops. What did you guys get? Yeah, 173.2 meters. Any questions there? Okay, let's keep going. Okay, let's keep going. Example 3, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? So in all of these questions, if they don't provide a diagram, you need to draw a diagram and then label everything in there. So I'm going to give you a second, again, to draw the diagram because that's half the battle, is drawing the diagram to set it up. Okay, so here is my tree, and here's the ground. Here is John, and he is at the horizontal looking up to the tree. So like I said, there is your angle, 33 degrees. And this is 100 feet from the base. So we want to know this height here. There's my 90 degrees, yes. There's John, J for John. Anyways, so that would be tan, right? So tan of 33 degrees is equal to the opposite, which is h, divided by adjacent, which is 100. So h is approximately 64.9. And that would be feet. No. 64.9407. Tenth is right here. Look to the right. The 4 would not round it up, right?